the last part of 5.1, or 5.4, part 1. That's what we called it. So number 2, it says factor the polynomials using any method. So we're going to look for difference of squares, difference of cubes, sum of cubes, factor grouping, GCF. We're going to look for all those different things. So in this one, I have 5mp squared minus 45m. So these two have a GCF, right? The GCF that they have in common is a 5 and an m. So I'm going to pull that 5m to the front. And when I do that, I'm left with p squared minus 9. So p squared minus 9 is the difference of two squares. It's p times p and 3 times 3. So I'm going to have p plus 3 and then p minus 3. So my final answer is 5m times p plus 3, p minus 3. Okay, on the next one, I have x cubed y cubed plus 8. So there's nothing that you can pull out. There's no GCF. So you have to identify what it is. So since there's two terms, it's either the sum or difference of two cubes or the difference of two squares. Okay, those are the only things that we'll possibly factor. So in this case, it's the difference of two, or the sum of two cubes. So I'm going to have something cubed plus something cubed. So I first want to identify what my a and my b are in the formula. Okay, so if I have xy times itself 3 times, that's what's giving me x cubed y cubed. And this next one I have 2 is being cubed. All right, so I'm going to do my 2 sets of parentheses, but it's a binomial and a trinomial, meaning 2 terms in the first one, 3 terms in the second one. Okay, and so in the first parenthesis, you just drop the cubes. You write xy plus 2. And in the second parenthesis, you square this first item. So the xy times itself gives you x squared y squared. And on the end of the parenthesis, you're going to square the second item, 2. So 2 times itself gives you 4. And then in between, in the middle, you're going to multiply these two things together. So you have xy times 2 gives you 2xy. And then in the end, your signs are same, opposite, always positive. So what we had before was a plus. So my same is going to be plus, right? And then my opposite is going to be a negative, and then the last one is always positive. So plus minus plus. Okay, so this next one's a little bit harder. So I have 64x to the 6th minus y to the 6th. So it says, hint, when you have the 6th power, use the difference of two squares first. So basically what I mean by that is that when I look at the 64x to the 6th minus y to the 6th, I could have written it 2 different ways. I could have done something squared minus something squared, or I could have done something cubed minus something cubed, actually. So if you look at it, 64 is really 8, right? 8 squared. So it's 8x cubed quantity squared minus y cubed quantity squared. That would be the difference of two squares format. But I could have also written it as the difference of two cubes. I could have said, well, 4 cubed is 64, so 4x squared cubed is 64x to the 6th. Does that make sense? And then this would be y squared cubed. But what I'm telling you is when you have something to the 6th power, it's going to make your life so much easier if you do the squares first. So we're just going to cross this one out. So we're going to ignore that. Yes, it could have been the difference of two cubes, but it's easier to do squares. So I have difference of two squares, so I'm going to break into identical parentheses, except one's going to be plus, one's going to be a minus. Just like if I had x squared minus 25, remember that breaks into x plus 5, x minus 5. Same idea here, right? So I'm going to have 8x cubed plus y cubed, and I'm going to have 8x cubed minus y cubed. But I'm not done. So I can see in the expression in some of your faces that you realize what we have to do now, right? Do you guys see it? So we have something cubed, right? Different, or sum of cubes, and we have the difference of two cubes. Okay, so I'm first going to identify what's being cubed. So on the sum of cubes, it's 2x is being cubed plus y is being cubed. And on the difference of two cubes, it's 2x is being cubed minus y is being cubed. So we're now going to break this into a binomial and a trinomial, a binomial and a trinomial. So the first one, from the 2x quantity cubed plus y cubed, I'm getting 2x plus y. I'm squaring the 2x and getting 4x squared. I'm squaring the y and getting y squared. And I'm multiplying the two together and I'm getting 2xy in the middle. My signs are same, opposite, always positive. And then same idea on the next one, so I'm going to just drop the cubes, so I have 2x minus y. Square the first item, 4x squared. Square the last item, y squared. Multiply the two together, 2xy. Same, opposite, always positive. That was a little close. You guys see it, 4x squared plus 2xy plus y squared. And that's your answer. When you do the difference of sum or difference of cubes, that trinomial part, it doesn't factor, unless it had been something really weird, like y to the 12th originally, that would continue going on. Yeah?
So how do you find 2x cubed plus y cubed?
So how do I find 2x cubed plus y cubed? I'm basically like taking the cube root of this. We'll talk about cube roots eventually, but I'm saying what times itself 3 times gives me 8x cubed. So it would be 2x times 2x times 2x gives me 8x cubed. Does that make sense? Yeah, it's usually something really small, like 2, 3, 4. Okay. All right, and then it says in the last section you learned how to divide polynomials with long division or synthetic division. So it says sometimes factors cancel, like with numbers. So for instance, if I had 45 over 25, right, 45 divided by 25, I can break it into its various factors, which would be 5 times 9 over 5 times 5. And then I notice that I have common factors of 5, so I reduce it out. So your answer would be 9/5. So it says you can divide the top and bottom by a common factor of 5, and you would end up getting 9/5. Same thing with polynomials. If you can factor them, go ahead and try to factor and see if it reduces. So I'm going to factor the top and the bottom. So I have, let's do the bottom first, it's easier. A squared plus 7a plus 10. You're going to need a plus 5 and a plus 2. See how the outer and inner combine to be 7? So we're good. All right, now the top, I want a squared minus a minus 6. So I'm going to need a minus 3 and a plus 2. That way they multiply to be negative 6, but then my outer and inner swoops do combine to be the negative a. So we're good. So we have a common factor on the top and the bottom. We have a plus 2, so we cancel it out. So we end up getting a minus 3 over a plus 5. That is your answer. Do not reduce by a. Okay, you can't reduce by a. Think about numbers. Like if I had 1 plus 3 over 4 plus 3. That would be 4/7, right? Can I reduce the 3's and say it's the same as 1/4? No, it doesn't work that way, right? You cannot do that. You cannot reduce out by things that you're adding or subtracting. So when you get stuck, think about plugging a number in. Like if I plug in 8 for a, I would have 8 minus 3 over 8 plus 5. That would give me 5 over 13. It's not the same as if I cancel. 5 over 13 does not equal negative 3 over 5, right? They're not the same thing. They're not even the same sign. It's not possible, right? So you cannot reduce out by a. A lot of people do that on their test. Like they get all of the work correct. They reduce out everything that they're supposed to reduce, and then they do this final reduction that doesn't make any sense. So don't have the right answer and then go too far, right? All right, and then at the very bottom of your notes, I had kind of a review of factoring. So it's kind of just a convenient place. It has all examples of all of them. So greatest common factor, you pull out the common factor. So we pulled out ab squared in that one. Difference of two squares, so if you had like x squared minus y squared, it's x plus y times x minus y. Difference of two cubes and sum of two cubes, the formula is given to you. Remember your SOAP, right? Same, opposite, always positive. If you have 3 terms, I would just do your parentheses, like your 2 parentheses. I do have something called a perfect square trinomial listed, which is where if you have x squared, let's say minus 6x plus 9, it factors into x minus 3 times x minus 3. Which you could write as x minus 3 squared. That's kind of what this is saying. Like, if you have double, it's kind of weird. If you have 2x times y, so if you notice that this is a square, like you can take the square root of this, and you can take the square root of this, and then when you multiply their square roots by 2, I don't know. It's hard to like recognize them in that form. So you guys can always just do your 2 sets parentheses if you need to. And then grouping is just splitting the middle. Okay. So those are kind of a review of all of those different things. All right. We're going to play a game first.